Hello viewers, you are welcome to this special episode of my tutorial which is titled Coordinate Geometry 1. Under Coordinate Geometry 1 we'll be looking at distance between 2 points, midpoint of a line segment, gradient or slope of a line, equation of a line, angle between two lines, parallel lines, perpendicular lines. We now solve exam questions. So we now move to the first one, which is distance between 2 points. Okay, distance between 2 points. Assuming you are given so this is our axis, this is our y-axis. Y, this is our x-axis. Let's call it y and x. So we are given 2 points. Let the first point be A. Let the coordinate be x1, y1. Y, the second point, B. Let's call it x2, y2. So our main aim is to find the distance between these 2 points. So our main aim is to find this. But if you look at this diagram now, we'll form a right angle triangle. Check it. So we'll form a right angle triangle. So we need to know the distance here, the legs. From here, this should be x2 minus x1. We assume that x2 is great, though it could be s1 minus x2. Here also is y2 minus y1. That's distance from here to here. That's the difference. Why the distance from here is the difference. So our main aim is to find AB, which is, let's call it D. So from Pythagorean theorem, which states that the sum of will form a right triangle. So the left triangle equals the sum of the squares of the legs equals the square of the hypotenuse. So I'm saying that D squared equal x2 minus x1 squared plus y2 minus y1 squared by Pythagorean theorem. So therefore we are asked to find D, the distance. So distance is now the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's our answer. So whenever you are given 2 points and you are asked to find the distance, just use this for example. Example, if you are asked to find the distance between point A, 1, 3 and B, 2, 5. So without wasting time, our answer, which is D, is now square root of, just call anyone x1, y1. So I will call this, let me call here x1, y1, y this is x2, y2. So without wasting time, my answer is 2 minus 1 squared plus 5 minus 3 squared. So which is square root of, this is 1 squared, 1. 5 minus 3, 2 squared, 4. So 4 plus 1 is 5. Our answer is 5, square root of 5. So again, you notice that the distance between 2 points will not be negative because you know distance is always positive. So the distance is either positive, therefore note D is always positive or 0. So whenever you are asked to find the distance, it's either positive or 0. Otherwise, the answer is wrong. So let's move to the second part, which is midpoint of a line. The midpoint of a line. So assuming you are given a line, okay, let's first draw the axis. Let's draw. So the second one. Okay, we are given 2 points. Remember, we have to find the midpoint of a line. And once you know 2 points, you've known the line. So assuming this is the first point, let's call it point A with x1, y1. This is our y-axis. This is our y and x-axis. Y the second point. Let's call it x2, y2. That's the coordinate. So our main aim is to find the middle of the line, the midpoint. So assuming this is the line, we have to find the middle. So let's call the coordinate of the middle. Let's call it x sub m and y sub m. So we want to know x sub m and y sub m. So what we note here, we formed a couple of right angle triangle with this. Yes. Also this. Also this. So you notice we form right angle triangles. So you notice that from here, for this to be the middle, from here to here, this is y2 minus ym. Y here is ym minus y1. Again, for this to be the middle, that's for this tracing here must be x m minus x1. Y here is x2 minus xm. So we are saying for this to be the middle, for x now, these two must be equal. That's the condition for the two to be in the middle of any line segment. The distance here must be equal to here. So let's find xm. So making xm the subject of formula, this comes here is now xm plus xm. Y here is x1 plus x2. So xm plus xm is 2xm. Y here is x1 plus x2. So therefore xm is now x1 plus x2 over 2. So this is for our x. For y, the same thing. For this to be the middle, here must be equal to here. The same way here is equal to here. So we are saying that y2 minus ym must be equal to ym minus y1. That's the condition for the two to be equal. So making ym the subject of formula, this is ym plus ym. Y this is y1 plus y2. So y1 plus y, okay, ym plus ym is 2ym. Y this is y1 plus y2. Therefore, y1 plus y2 over 2 must be equal to ym. So this is our coordinate of the midpoint. Therefore, our coordinate of midpoint is the average of the coordinates. So once you are giving an example now, let me give a quick example. If you ask to find the midpoint of the line joining A 2, 4 and B 5 or maybe 6, 8. So without wasting time, the midpoint of this line, the coordinate of the midpoint, the coordinate is just 2 plus 6 over 2, comma 4 plus 8 over 2. That's the answer. You don't need to waste your time, which is 2 plus 6 is 8. So 8 over 2 is 4. Why 4 plus 8 is 12. 12 plus, so that's the coordinate of the midpoint. So you don't need to waste your time. The next one, a gradient of or slope of a line. The gradient of a line is just the measure, is the measure of the steepness of the line. Is the measure of the steepness of the line. So once we talk about slope, we are talking about a slant line. That's what we are saying. It must be a slant line. So let's get an expression for that. We normally denote it. It is denoted by French word. The first letter of it is French word M. So let's derive the assuming okay, this is my x and y, this is y and this x. So assuming you have a line okay, let's draw the diagram. Assuming, let me have this. This is my x, this is my y, this x. Assuming I'm to find the gradient, which is the measure of the steepness of the line. So this is my y and this is my x. So it's just assuming the coordinate is this x1, we need the points, we need 2 points, x1, y1, y d6, y2, y d is what? X2. So the slope of this line, we must form a right angle triangle for us to get the slope. So if you have the measure, from here is y2 minus y1, y here is x2 minus x1. So we are saying the slope of this line, m, is always the change in y over change in x, which is y2 minus y1 over x2 minus x1. Though it could be y1 minus y2 over s1 minus, they are the same. They are the same. You can check it. Okay, is the formula for the slope of this line. Again, we want to introduce something that is very assuming we make an angle theta with the x-axis, positive x-axis, we can still find the slope of this line in terms of theta. we can derive is C. This is theta now. Assuming this is the angle made by the positive x-axis. You notice that this is also theta by corresponding angle theorem. So from here, from our trigonometry, tan theta is always opposite over adjacent, and from here our opposite is y2 minus y1, and our adjacent is also x2 minus x1. And looking at this, I think we have something we've known before. Here, this is the slope, check it. So from here, the slope is also, therefore the slope is also the tangent of the angle made by the line with the positive x-axis. So meaning that even if you are not given 2 points, you can still find the slope if you are given the angle. Example, if you ask to find the slope of a line that makes an angle 45 degrees with the positive x-axis. So we asked to find the slope of this line without wasting time. The slope m is just tan 45, which is 1. So you don't need to waste your time. So if you are to find the slope of a line, either you are given 2 points or you are given the angle made by that line with the positive x-axis.